Good evening, everyone. My name is Elizabeth, the Education Coordinator for Marlene's Market and Deli. Tonight's special guest, and we are always honored to have her expertise with us. We have Dr. Adrienne Wilen, naturopathic doctor at Federal Way Naturopathy, and she's speaking on the topic tonight, your turkey dinner. Where does it go? Thank you so much, Dr. Wilen, for joining us.
Thank you. I'm excited to be here and talk to everyone about the digestive system. I think it's really important to understand where things start and where things end so that if anything's wrong in the process, we can figure out where exactly it is. Um, like you said, I'm Dr. Adrienne Wilen. I practice at Federal Way Naturopathy. I've been there about 3 years in primary care with a special interest in gastrointestinal health. So, we are going to talk today about your turkey dinner since it's almost Thanksgiving and where does it go? So, first off, just a little disclaimer, none of this is medical advice. This is all for educational purposes. And then we can go ahead and get started. So, this presentation is meant to give you some background information on digestion. May seem a little bit science and information heavy, but it's really important to understand what is going on in your body during digestion so we can optimize that process. So, we're going to start out with the journey your turkey or tofurkey even will be traveling. So, Hippocrates once said, bad digestion is the root of all evil, and he wasn't wrong. Our gastrointestinal tract is literally at the center of our body, as you can see in this picture, and it can impact everything from our mood, memory, immune system, musculoskeletal health, hormones, skin, so much. So, let's get started and see what happens during ideal digestion. So, take a look at this whole digestive system in this diagram. It is made up of a twisting hollow tract from where the food goes in to where the food goes out. The hollow organs are the mouth, esophagus, stomach, small intestine, large intestine, and anus. And then we have the solid organs, which are the liver, pancreas, and gallbladder. And those are accessory organs with only a one-way connection to the tract. Digestion is the process of your body breaking down food and beverages to obtain the amino acids, fatty acids, sugars, vitamins, minerals, all the good things that it needs to create energy and cells. So while food travels through your gastrointestinal tract, it is both mechanically and chemically broken down. So starting at the top here, process doesn't really start when you eat, but when you sense food in general. So your eyes and nose are actually your first organs involved in digestion. When your body senses food, your autonomic nervous system stimulates those salivary glands to start releasing saliva into your mouth. Approximately 1 liter of saliva is secreted each day, so quite a bit. Once you take a bite, your salivary glands then release a protein called salivary amylase. So this is an enzyme that breaks down carbohydrates. Saliva also contains lysozyme, which has antimicrobial properties to help destroy any germs that come in along with your food. The act of chewing creates a mechanical force to break down the food and then move it along the digestive tract. When you swallow, your tongue pushes the food, now more mushy due to the addition of saliva and crushing from your teeth, down the back of your throat, past your epiglottis, and into your esophagus. The epiglottis is a little skin fold that folds over your trachea to prevent getting food in your lungs and causing choking. Once you swallow, the rest of the process becomes automatic. So that's basically all you have to think about at the beginning. You need to focus on chewing, but you don't really have to think about digesting because your enteric nervous system takes care of it. So while your central nervous system controls your subconscious processes like breathing and all of our conscious movements and actions, we have an entire other nervous system controlled mostly by the vagus nerve working in the background. So this is a nice picture of all those salivary glands. Next up, we have the esophagus, which then uses peristalsis. So it's a constriction and relaxation pattern that creates a wave-like motion to move that bolus of food from your throat to your stomach in approximately 7 seconds. So it's pretty fast. When the food reaches the end of the esophagus, the lower esophageal sphincter relaxes to let food pass into your stomach. The sphincter then closes back up so that stomach acid can't enter the esophagus. When there's an issue with this closure, we can get reflux of food and acid into the esophagus, which causes the feeling we know as heartburn. The top of the stomach lies just below the end of your sternum, right below your diaphragm, and then curves down to the right where it meets your small intestine. By the time your food reaches the stomach, it is primed and ready to digest due to the vagus nerve stimulation from seeing, smelling, and tasting food. In the stomach, the food is then broken down and mixed with a concoction of different digestive juices produced by different cell types in the stomach. You have a mix of hydrochloric acid, which at a pH of 2 kills bacteria and converts pepsinogen, another enzyme, into pepsin that can then digest proteins. Your stomach also produces what's called intrinsic factor, which binds to vitamin B12, specifically only B12, and allows for absorption later on. It's one of those hard vitamins to absorb. Your stomach is also lined with mucus, so this prevents the acid from actually breaking its own cells down. Then, once the food is thoroughly mixed with that digestive slurry, it is referred to as chyme. The stomach uses two alternating types of movements: paracelsic wave, like we talked about with the esophagus, and then a mixing wave. This is made possible because there are 3 different layers of muscle, all with different orientations in the stomach lining. Each contraction occurs about every 20 seconds, and it starts at the top of the stomach. So, looking at right here with that fundus, and then goes down into the body and down into the greater and lesser curvature. So, lasting about 20 seconds, the stomach's mucosal inner layer has large folds that stretch, and receptors in the folds then stimulate the secretion of the digestive enzymes when they are stretched. So, think your little stomach, and then you're putting food in it and it's getting bigger. And the receptors in these folds are stimulating those digestive enzymes. Then the gentler mixing waves move the liquid portion of the chyme. Oh, sorry about that. Okay, back to that screen. So liquid portion of the chyme tied towards that pyloric sphincter. So that's the pyloric canal and pylorus down there. And then when we get there, it pushes the more liquid stuff out of the sphincter, and the more solid chyme will go back up into the stomach and go through the process again so it can be broken down more. So then the pyloric sphincter will remain closed during a mild contraction, so only a little bit of the fluid really passes through with each wave. The speed at which our stomach churns food is really crucial for correct digestion. If there's an issue with that rate, we can get gastroparesis, or the opposite, which is called dumping syndrome, so either too slow or too fast. And any disruption in that rhythm can cause what we feel as nausea. So that's how your brain interprets something wrong in the stomach. So ways that you can kind of help your stomach and digestive system. So from the mouth all the way down to the stomach, it's really focusing on sensing your food. So seeing it, smelling it, tasting it. Really think about chewing your food thoroughly. About 20 to 30 bites per chew is what's recommended, which seems like a lot, but if you get there, you can see how much you're actually breaking it down. Your mouth is the only place where that mechanical digestion occurs, so really important to get that done there. And then once you swallow, remember your enteric nervous system takes over from there. You can assist your body by putting energy towards this process by relaxing, taking deep breaths, and not focusing on other things like TV or your phone while you eat. Work on chewing each bite, swallowing it before putting another bite of food in your mouth, and give your stomach time to stretch so that you can be aware of signals from your brain that you're full. Bitter tasting herbs, commonly referred to as bitters, are also a great way to support that start of digestion. used in many cultures to support that upper activity. The stimulation of bitter receptors on the tongue act reflexively to increase saliva, and that vagal stimulation to increase the other digestive secretions as well. So, triggering those bitter receptors before eating, like 10 to 15 minutes about there before, can help prime your digestive tract for the incoming food. Marlene's carries a variety of liquid bitters. Urban Moonshine is a great place to start with those. Remember, the bitters actually have to contact the tongue directly, so capsules do not stimulate bitter receptors. It will either be in a tincture, glycerite, some sort of liquid form. Some, like wormwood and gentian, are really incredibly bitter, but there are some more palatable starter bitters for those who need a little intro to bitters, like ginger or licorice root. And then from the stomach, your food is going to travel into the small intestine. Your small intestine is 6 meters long, and it's made of 3 different parts. First one is the duodenum, then the middle is the jejunum, and the last part is the ileum, which connects to the large intestine. In the duodenum, peristaltic movements continue, and those digestive enzymes are injected from the liver and the pancreas. So remember, our solid organs that just have the one-way ticket into the tract. So when that highly acidic chyme enters from the duodenum, remember, stomach, really acidic, pH of 2, that change in pH triggers the release of secretin, which is an enzyme that inhibits gastric secretions in the stomach. Fatty acids and peptides initiate the release of cholecystokinin, which has the same action. So that slows down the stomach as the food moves past it. This is called a negative feedback loop, where the end product signals the start of the process to decrease. So things going into your small intestine, slow down your stomach. So back to those solid organs. The liver produces bile, which is stored in the gallbladder. Both the liver and gallbladder will release bile into the duodenum from the common bile duct in response to the vagus nerve, secretin, and irritation to the duodenal cells from the acid in the chyme. Bile is made of bile salts, cholesterol, fats, bile pigments, all these great things that neutralize stomach acid and emulsify fats. When we don't have enough bile, or when we have too much bile, fats are not digested correctly, and we have malabsorption of fats, fat-soluble vitamins like D, A, E, and K, and overall, not a good thing for your body. Gallstones can also form if the amount of cholesterol secreted by the liver is too much to be dissolved by the bile salts. Then we've got the pancreas. This one injects bicarbonate ions to, again, help neutralize that stomach acid, and also another slew of digestive enzymes that digest proteins, starches, and fats. So it does this in response to that secretin and that cholecystokinin. Pancreas is actually made up of 2 types of tissue. It is an endocrine organ, so meaning it produces hormones like insulin and glucagon. So that controls your blood sugar and blood amino acid levels. And then it's also an exocrine organ, meaning it produces those digestive enzymes. So pancreas has 2 different jobs. From there, we are thinking about the entire small intestine. So it is made of circular folds that are covered in little teeny projections called villi, which are then covered in more little teeny projections called microvilli. So this really increases that surface area for absorption to occur. There are also goblet cells that produce mucus, glandular cells, which help with the protect the epithelial lining from bacteria, endocrine cells, which produce regulatory hormones. So each secretion in the small intestine has a different ratio and a different type of gland. Lots of different things going on in there. We also have Peyer's patches, which are small groups of immune cells. So those are found along the length of the small intestine and help protect from pathogens. So if a pathogen gets over there, it can send out an immune response. The walls of the small intestine have enzymes that are connected to the cells as well. So these are not released into that slurry that goes through. They're always there. So these tethered enzymes include peptidases, which break down proteins, amino acids, disaccharides, and then disaccharidases that break down those larger sugar molecules into glucose. So then these small particles can be absorbed by the intestinal epithelial cells. Big ones cannot. Again, contracting waves like those in the esophagus move that chyme through the length of the small intestine. The contractions are segmented, which allows for mixing as well as forward movement. So, one of the main functions of that small intestine is absorption. Most of the absorption occurs in the duodenum and the jejunum, but some of it, like that B12 that's now bound by intrinsic factor, and the reabsorption of bile salts occurs in the ileum. So, all of these parts are really important. Now, let's circle back to the liver. So, we've got the absorption, and we've got all these things and cells that have come from your food. So, then the liver receives the blood, so things get absorbed into your bloodstream. Then it goes through the bloodstream to the hepatic portal vein. So everything absorbed by your small intestine, which isn't too picky with what it's absorbing, then enters the bloodstream and is transported via the hepatic portal vein into the liver where it's processed. So the liver is processing everything that goes through your mouth. The liver cells process nutrients, they detoxify harmful substances, anything that goes through the small intestine. So then that filtered blood can then exit the liver and return to the heart. Liver cells also store sugars, fats, fat soluble vitamins, copper, and iron. The body can't store protein, so what is not used is then broken down and stored as glycogen or lipids. The liver also converts vitamin D into its active form and synthesizes new blood proteins from all the amino acids it collects. So, really, really important organ. And again, while you may not be able to improve this stage of digestion with your conscious mind, thinking back to that digestive bitters, they can really help stimulate your gut to produce more of the digestive enzymes, to help break down the food, to help stimulate adequate blood flow through the digestive tract to carry nutrients to your liver for processing. So now we have passed about 3 to 5 hours since you initially ate that turkey dinner. The turkey dinner, which is now chyme, passes from the small intestine into the large intestine at the ileocecal junction. So this has a sphincter and a valve to ensure that the movement is unidirectional, so small to large only. The large intestine consists of the cecum, colon, rectum, and anal canal, as well as the accessory organ, the appendix. Your large intestine is about 1.5 to 2 meters long, and it's full of mucus producing glands called crypts. Digestion really slows down in the large intestine. From this point, it takes about 18 to 24 hours for material to pass entirely through. And then, as it's processed, that chyme becomes feces. The large intestine's job is to absorb water and salts. It secretes mucus and allows for digestion by our commensal gut bacteria as well. Every 8 to 12 hours, the large intestine undergoes several strong contractions called mass movements, which moves the feces a great distance all at once. So we've got little movements until that mass movement is really pushing things along. Mass movements are common following meals, especially breakfast. So a lot of people will have that morning bowel movement because of that mass movement that's occurring in the colon. Let's talk about your microbiome in your large intestine. So there are trillions of bacteria in there, more than any other part of your digestive tract. They form a symbiotic relationship with your host, meaning they work together by breaking down ingested matter that humans do not have the enzymes to break down themselves. Colonization of the gastrointestinal tract above the large intestine is rare and problematic. It can cause issues like gastritis in the stomach, SIBO in the small intestine. Basically, we want to keep the majority of the bacteria, especially fermenting bacteria, in the colon. Acid in the stomach usually kills those incoming bacteria, but if you have low stomach acid, you might have that reduced antimicrobial activity. bile is also antimicrobial. So thinking about when things pass into the small intestine, and that one directional movement of peristalsis keeps bacteria in the large intestine from moving backwards in the digestive tract. When motility is slowed due to slow transit, constipation, anything that's slowing down things in the colon, bacteria do have the opportunity to move backwards into the upper GI tract. Again, rare, something we don't want to happen. At the end of your colon is the muscular rectum and anal canal. Your anal canal has two sphincters, the internal and the external. The rectal wall senses the stretch caused by the feces building up in that region, and then is going to activate the defecation reflex. So, this is the feeling like, I need to go. The signals produced in response to the stretching also allows for the sphincters to relax for stool to pass through. The internal sphincter is controlled by the enteric nervous system, so not your conscious thoughts, but then that external sphincter is not on autopilot, and we need to voluntarily relax it to allow stool to pass. A quick aside on pooping posture. So there is a muscle in your pelvic floor called the puborectalis muscle, as you can see. So this is important for continence. So thinking incontinence is when fecal incontinence, we've got some leakage, you're going to the bathroom when you don't want to. So to maintain continence, that puborectalis muscle chokes the rectum to close off the anal canal. So it keeps a really tight grip on it. Squatting relaxes that muscle and then also straightens the angle of the rectum, allowing for easier passage of stool. So that's why things like squatty potties exist. And there we go. We have made it all the way through. By the time your turkey dinner exits your body, you will already be done with your Black Friday shopping. All right. A lot of stuff in that presentation. Any questions?
Thank you so much, Dr. Wilen.
You are very welcome.
Um, I was blown away about how much time it makes to the how you have to give time to make the chyme.
Yes, every part of the process has a very interesting and very different time frame. So when things are happening quicker or faster, we can kind of use that time frame to diagnose any issues that might be going wrong.
That's wonderful. And I was wondering, so with like typical holiday feasts, um there's a lot of carbs, but do you think that there's possibly enough fiber in a holiday meal? And if not, maybe everyone should be doing some bran muffins for dessert, maybe.
Yes. So probably not. Thinking of your traditional meal, you've got like turkey, so protein, a lot of carbs. We've got potatoes, we've got rolls, all sorts of things like that. There are also fiber sources, I guess, with those vegetables, thinking about like green beans and salad. But I would say probably not. Again, we're aiming for like 30 grams of fiber a day. So what we talked about in like my previous fiber presentation was how things don't quite have as much fiber as a lot of people think they do. So thinking about a cup of lettuce is like a gram of fiber, whereas we've got a cup of beans is your whole 30 grams of fiber for the day. So being mindful of fiber during your turkey dinner is really going to help you with that digestion and feel better the next day as well.
Thank you. That's a really wonderful point. Yeah, because I was thinking about it when you were presenting. I was like, "Ooh, I'll have to ask her about fiber because that wonderful um fiber is the fourth macronutrient
Mhm.
presentation you did last year was wonderful. So
Oh, thank you.
you're welcome. I also wanted to ask, um, so with how like there is like some charts out there. It's like um oh, if like you have this type of stool, you might be dealing with this, or like um with um with the holidays coming up, everyone's going to be feasting a lot. And what would be some suggestions for people as they're going through the holidays to make sure that they're good and regular?
Yes. So what you're talking about, I think, is a Bristol stool chart. So we've got like all the little pebbles all the way into liquid stool, with the middle ground being like normal and ideal stools. So fiber is going to be really important. Also, water. So thinking of all of the salty things that are served during Thanksgiving, um, really important to make sure you're getting enough water. Thinking about even adding some electrolytes to that water, because your digestive tract pulls in a lot of water. And it also, your large intestine then reabsorbs a lot of water. And so if things aren't moving fast enough, or if your body, your other cells are like, hey, I need more water, it's going to absorb more. And so you're going to have harder stools and eventually be more constipated. So that's a great way. Water, fiber. Probiotics are also really helpful in just keeping things balanced, especially if you are eating foods that you don't normally eat. So typically, we don't all eat mashed potatoes and turkey and rolls every single day of the week. So having some sort of probiotic with some good healthy bacteria is going to help you break everything down.
Perfect. Yay. Well, I feel way more set up for the holidays, and um I'll be um I'll be eating my turkey dinner being like, "Yay, go body, go."
Good. Your bitters beforehand, drink lots of water.
Yes. And have plenty of fiber to make sure everything's moving and a grooving.
Yes, definitely.
Oh, let me check here if there's any questions on Facebook Live.
All right.
Looks like we are good here. Um, well, I thank you very much, Dr. Wilen, for your expertise, and looking forward to having you for 2024.
Yes, excited for all the new topics. Thank you for having me and letting me talk you through your Thanksgiving dinner and all that digestion going on.
Oh, yes. And y'all have a lot of wonderful info to digest on. So thanks for watching.
Perfect. All right. Everyone, have a happy holiday.
Have a good one. Happy holiday.